because I'm little bit occupied today. Is the screen visible, all of you? I hope the screen is visible. Okay. Right. So it's not necessary to study physics, technology, and society, guys. Okay, whichever are necessary, I'll just quickly give a recap of that. Right. So whenever we talk about unit, guys, so what do we mean by unit again? Any reference standard. Basically, when we consider measurement, it is again process of determining how small or large a physical quantity is with respect to some reference standard. So that reference standard only will be called as unit again. So whenever we define a physical quantity, we should write its numerical value and we should also represent its unit again. So what is this? You can take n into u. So if you want to measure any physical quantity, so to measure any physical quantity, you require n and u. What is n here? N happens to be the numerical constant and u is the units again. Right. So any physical quantity, to represent any physical quantity, I require these two things again. What are those? The numerical value as well as the unit. And always remember, n into u, you take any system of units, n into u will remain constant. Whether you take FPS, whether you take MKS, whether you take CGS, right, whether you take SI unit, n into u will always remain constant. So we have different types of units again, fundamental quantity, we have different types of quantities. So units and measurements. What is measurement? Right. So in order to define measurement, first we should know physical quantity. What is a physical quantity? Any quantity that can be defined and measured is called as physical quantity. What is measurement again? It is just a process of determining how small or large a physical quantity is with respect to some reference standard, and that reference standard is only called as unit of a physical quantity. Unit is nothing but the basic reference standard. Measurement is just determining how small or large a physical quantity is, right? And whenever we talk about a physical quantity, any quantity which can be defined and measured will be called as your physical quantity. They can be categorized into two types again. What are those? Fundamental quantity, which are also your base quantities, and derived quantities, right? Which will be represented as the combination of two or more fundamental quantities. So we have 7 fundamental quantities again. We should remember that, because when we talk about dimensions of any physical quantity, we represent them in terms of fundamental quantities again, right? So length, mass, time, temperature, electric current, amount of substance, and intensity, light intensity. These are your 7 basic quantities or fundamental quantities. Any other quantity, right, if you consider, we will write it as the combination of these quantities. So quantities derived from fundamental quantities will be called as your derived quantities. Again, different types of units you have. So you take any type of unit, n into u will always remain constant. The numerical value into unit will always remain constant, guys. Is that clear? Then we talk about dimensions. So what are basically dimensions? They are simply fundamental quantities raised to some power. What are they? They are fundamental quantities raised to some power. So if I want to find dimensions of any physical quantity, as you can see, dimensions of a physical quantity are powers to which base quantities are raised. So if you want to represent force, I should represent in terms of the 7 base quantities or fundamental quantities raised to some arbitrary powers again. Clear, all of you? Yes or no? Right. So again, we will talk about how to perform dimension analysis and all, how to find the dimensions of any physical quantity. We'll do that. So remember what are fundamental quantities, right? And dimensions will always be represented in square bracket. Okay. Length will be represented in this manner. Length, mass, you can write in this manner. Time is this. Length, mass, time. Then we have electric current will be written as A. You can take temperature, right? Similarly, we have number of amount of substance, which is mole, and light intensity we can take it as CD again. So these are your fundamental quantities or dimensions of fundamental quantities. These are dimensions of length, these are dimensions of mass, dimensions of time, dimensions of electric current, right? In the same manner, we have dimensions of temperature, then we have amount of substance, as well as light intensity or luminous intensity we call it as. We have amount of substance and luminous intensity, or light intensity we can consider. So whenever we write dimensions of any physical quantity, we should represent them in terms of these fundamental quantities only. So there are different physical quantities whose dimensions are given, right? So there is no necessity to remember all these guys. If you know the formulae, how to get capacitance, it is charged by potential difference. How to get potential difference, it is electric field into separation. How to get electric field, it is force by charge, right? So basic quantities, if you know, you will be able to solve all the questions again, right? So let us talk about dimension analysis again. Very basic points you should know in dimension analysis, guys. What are those basic points? Whenever we add, subtract, compare, right? I can use these mathematical operations only with physical quantity which have same dimensions, guys, right? Addition, subtraction, and comparison can only be done with physical quantities of same dimensions. However, when we talk about multiplication and division, guys, right, they can be done with physical quantities of any dimensions. You can add or subtract or compare if physical quantities have same dimensions, guys. You can multiply or divide physical quantities of any dimensions, right? Whenever we take power should always be dimensionless, right? Trigonometric ratios, logarithms, exponential functions, numerical constants, these are all going to be dimensionless, guys. These things you should be aware of. Addition, subtraction, and comparison should be done with physical quantities of same dimensions, right? Multiplication and division can be done with physical quantities of any dimensions. If you take power to a number, power will always be dimensionless, right? Trigonometric ratios, logarithms, exponentials, numerical constants, they're all going to be dimensionless, guys. And always remember, if a physical quantity doesn't have a unit, unitless will always be dimensionless. However, dimensionless need not necessarily be unitless. Based on that, you got a question last year. Angle, you got, guys. Angle has units, but it doesn't have any dimension, guys. Right? So if they're asking you to convert units again, so as I said, you should use n into u will remain constant, guys. So n1 into u1 will be equal to n2 into u2 again. This case you can remember. Now, how to find relation among the different physical quantities? This is performed by dimension analysis again, right? So how will you do that? Suppose if they are asking us to represent, as you can see here, or let us imagine they're asking us to represent. They're asking us to represent. Let us consider absolute permittivity in terms of, you can say, force, in terms of charge, in terms of distance, right? So what are they asking us to represent? They're asking us to represent absolute permittivity in terms of force, charge, and distance. So basically, what are fundamental quantities? Seven fundamental quantities. Now, what they say is, in questions they'll also say, if force, charge, and distance is considered are considered as fundamental quantities, what will be dimensions of absolute permittivity? So always remember, there are only two steps that you need to remember, guys. Whichever dimensions are asked to be calculated, that you will take on left hand side, right? In the same manner, in whosever terms they are asked to be calculated, right, you will take them on right hand side, and you are going to raise them to some arbitrary powers a, b, and c, guys, or x, y, and z. Always remember, whichever quantity is asked to be calculated, the dimensions of whichever quantity is asked to be calculated, you will take that quantity on left hand side. In whosever terms it is asked to be represented, those you will take on right hand side, and you will raise them to some arbitrary powers a, b, and c. In the next step, what will you do? In the next step, you are going to substitute their dimensions, guys. So if you talk about dimensions of epsilon naught, mostly, let us say I don't remember them, right? Force value, if you consider, we know force value will be written as mlt power minus 2 whole power a. Again, charge can be written as current into time, guys. So I'll write it as a into t whole power b. Then r is nothing but distance again, so you can write l power c. So right hand side, what do we get? We'll get it as m power a, l power a plus c, t power minus 2a you will get, then you will get plus b, then a power b you will get. Okay. Then in the same manner, epsilon naught dimensions, if I say, it is given as Coulomb square per Newton meter square, guys. right? Coulomb square will be, right, a square t square you will get. Newton meter square means ml t power minus 2, meter square will be L square again. So what I'll get it as, I'll get it as m power minus 1. L cube you have, so you can write it as L power minus 3, then t power 4 a square. Now what will you do? You will simply substitute, right? Whatever are the powers. So if you see what is the power of mass on right hand side, a. On left hand side it is minus 1. So a value will get minus 1. Right? What is power of L on right hand side? A plus C. On left hand side what is it beta? Minus 3. So a already we know it is minus 1. Implies what will I get C value as? I'll get it as minus 2. Then a dimensions of a is are b on right hand side. On left hand side it is 2. So we got the values of the variables. Now what I'll do, I'll simply write epsilon naught as f is raised to the power a, which will be minus 1. Q is raised to the power b, which is 2. Then r is raised to the power c, which is minus 2. This will be how you will perform. Very simple logic, guys, again, right? Whenever a quantity is asked to be represented in terms of some other quantities, what you will do, you will take that quantity on left hand side, in whosever terms it is asked to be represented, you will take them on right hand side and raise them to some arbitrary powers, guys. Then in second step you will substitute their dimensions, calculate the values of the variables a, b and c. Finally you will write epsilon naught will be f raised to the power those variables minus 1, q raised to the power 2, r raised to the power minus 2. This is how you will perform dimension analysis. Clear, all of you? Understood, everyone? Now what are the limitations of dimensional method? Again, very important case, guys. It cannot be used to derive equations which involve addition and subtraction. So in any equation, addition or subtraction is there, you cannot deduce that particular formula again. In the same manner, numerical constants also, if numerical constants are there, cannot be obtained by the methods of dimensions. Similarly, in any equation, if you have trigonometric ratio, exponential, logarithm functions, they also cannot be deduced. And one very important point that you have, this third is very important point. Dimensional method fails when number of variables is more than number of equations obtained. So here we have 3 variables, but I'm going to get 4 equations, guys. So I'll be able to solve it. But let us say I have 4 variables and I have only 3 equations. Then I'll not be able to solve that, guys. Clear, all of you? Right? So whenever in a equation you have addition or subtraction, that equation cannot be deduced by using dimension analysis. In any equation, if you have numerical constant, that equation also cannot be deduced by using dimension analysis. In the same manner, in any equation, if you have trigonometric ratios, logarithms, right, exponentials, those equations also cannot be deduced by performing dimension analysis. Also, dimensional analysis will fail when number of variables is more than the number of equations that we are going to obtain. Clear, everyone? Yes or no? Right, so these are already I've discussed, so not that much necessary, guys. Right, so they are talking about accuracy and precision. So what is accuracy? See, whenever we take any physical quantity, it has some true value, guys, right? And you take some other values and you will try to compare it with the true value or actual value. Whichever measured value is closer to the true value, that value is said to be accurate. So what we can say, it is just simply the degree of closeness of a measured value to the true value. This is called as accuracy. Whichever measured value is near to the true value, that value will be called as a accurate value, right? And what is a precise value? Right, you can measure, you can take a measured value up to 1 decimal place, you can take a measured value up to 2 decimal places, you can take a measured value up to 3 decimal places again. So more the number of decimal places means more will be the precision again. So it is the measure of the extent to which measurement can be taken again. To how many decimal places a measurement can be taken will represent a precise value. Always remember, accurate value can be precise. Precise value need not be more accurate again. More the number of decimal places, more will be the precision. If the measured value is closer to the true value, that value will be called as a accurate value. Right? More the decimal places, more will be the precision. But more precise need not be more accurate. More accurate can be more precise. Clear, all of you? Suppose if true value is not mentioned, always remember, if true value is not given in the question, then more precise value will be taken as most accurate value. If true value is not mentioned in the question, then more precise will be taken as more accurate. And as we know, in any measurement you take, you will have some certain values, some uncertain values, right? All the certain values in the measurement as well as one uncertain value will give us what, beta? They are going to give us something called as significant figures. So if we consider significant figures here, what are significant figures? They are number of digits in the measured value which are certain, and one digit which is uncertain. Okay, so number of digits in the measured value about the correctness of which we are sure, means we are certain, plus one more digit. Okay, so that would be your, so you can see the number of digits, the correctness of which we are sure, plus one more digit. So certain values, whatever we are certain, certain digits plus one more digit will be called as your significant figures or significant digit. Now when I talk about significant figures, there are certain rules again. All non-zero digits will be significant, guys. Zeros between two non-zero digits will also be significant, right? If you have trailing zeros, means zeros which are at the end, guys, trailing zeros are there in a measured value with no decimal point, they will be insignificant. Trailing zeros are there in a measured value with a decimal point, then they are going to be significant. So if you can see, if number ends in zeros that are not to the right of the decimal, the zeros are not significant. So if the zeros are to the right of the decimal, when I say right of the decimal, they will be significant. It is not that it is necessarily in right of the decimal, guys. This will make a wrong sense again. So what I said, you please remember that. Whenever we have trailing zeros, means if zeros are there at the end of a measured value, trailing zeros in a measured value without a decimal point, insignificant. With decimal point, significant. And if a number is less than 1, right, so all those zeros before first, if you see this number, it is a number less than 1, right? So this is the first non-zero digit. All the zeros before first non-zero digit, they are going to be insignificant, guys. Okay, they will be what? Insignificant. Clear, all of you? These are certain rules that you should be aware for finding out the significant figures. All non-zero digits, significant. Zeros between two non-zero digits, significant. Trailing zeros means zeros at the end. If decimal point is not there, insignificant. If decimal point is there, significant, right? And if a number is less than 1, zeros before first non-zero digit will be insignificant, guys, right? In the same manner, whenever we are writing it in the form, so as you can see, you have taken a into 10 power b. In this form you have taken, how many significant figures are there? I'll ask you. You will have same number of significant figures as there are in this value. You see this also, guys, 1.500 into 10 cube, right? How many significant figures will be there in this value? Again, it will be whatever significant figures are there in 1.000. So whenever a quantity is represented in the form a into 10 power b, that quantity will have same number of significant figures as there are in a. Pure number, they say, have infinite significant figures, but that is an ambiguous statement. Let us not focus on that, guys. These are certain rules that you should know while finding out the significant figures. Now, majorly from last 2 years, questions have been asked in rules for arithmetic operations, guys. A very important case again. Always remember, whenever you are adding or subtracting, what we need to retain, you need to retain decimal places. How many? Least number of decimal places. So whenever you are adding or subtracting two quantities, what should you retain? It should retain as many decimal places as there are in a number with the least decimal place. Suppose if I take two physical quantities, one has two decimal places, other has three decimal places. We are adding them, or let us say we are subtracting them. So what we should retain in that physical quantity? You should retain two decimal places, guys. So very important case. And always remember, if you are multiplying or dividing, what do you need to retain? Significant figures. How many? As many as there are in a quantity with least number again. So blindly remember, if you are adding or subtracting, what do you need to retain? Decimal places. How many? Least number. While you're multiplying and dividing, what we should retain? Significant figures. How many? Least number again. As simple as that. Clear, all of you? Yes or no? We also have rounding off. You study this in chemistry also, guys, right? So whenever, if you're dropping an insignificant digit, if the insignificant digit is greater than 1, then greater than 5, what will you do? You will just add 1. If it is equal to 5, what will you do? You will see two cases, guys. If the preceding digit is odd or even, you will see. If the preceding digit is odd, you will add 1. If it is even, no change, guys. Yes or no? If it is even, then you don't have to make any change. If it is less than 5, obviously you are not going to make any change. These are the three ways in which you are going to perform rounding off of a rounding off of any physical quantity, guys. If the digit to be dropped or if the insignificant digit to be rounded off, if it is greater than 5, then preceding digit should be raised by 1, right? Then preceding digit should be raised by 1. If the digit to be dropped is equal to 5, then you need to check whether the preceding digit is odd or even. If the preceding digit is odd, you will raise it by 1. If it is even, you will not change. And if the digit to be dropped is less than 5, then obviously you are not going to make any change. Right? So what we have basically studied till now, again, majorly dimension analysis, guys. Right? How to represent one physical quantity in terms of other physical quantities. Right? Then we have seen which type of equations cannot be deduced by using dimension analysis. We have also seen, you take any type of uh, system of unit, the numerical value into unit will remain constant. N into U will always remain constant. Then we have talked about significant figures, right? How to find out the significant figures and rules for arithmetic operations. Let us quickly review errors in measurement, guys. So whenever you take a measurement, there will always be some uncertainty associated with it. Uncertainty in measurement is only called as error in measurement, guys. So always you see there will be a true value and there will be measured values, guys. So if a1, a2, a3, so on be measured values, how will you calculate the correct value of the physical quantity or true value of the physical quantity? Again, this you will take simply mean, guys. You will add up all the physical quantities, all the measured values divided by total number of values. This will give us mean value of the physical quantity. Then, with every measured value, you will have some error. That error will be called as absolute error. So, how will you find absolute error in any in any measured value? It will be mean value minus measured value, and it should always be kept in magnitude, guys. Absolute error will always be positive. Should always be kept in magnitude again. Right? Very simple logic, guys. Whenever you take any physical quantity, you try to measure it, there will be an uncertainty with it. That uncertainty is only called as error, guys. Right? So whenever you want to measure a physical quantity, it will have one true value, exact value. So in order to find that true value, what we do? We perform the experiment, we repeat it, and we take down the measured values. So if a1, a2, a3, so on are the measured values, then the mean value or true value of that particular quantity will be given as sum of all the measured values divided by total number of values, measured values. With each measured value, again there will be error, guys. Right? With each measured value, you are going to have error. That error is called as absolute error. How will you find the absolute error? It will be mean value minus the measured value in magnitude, and always remember absolute error will always be positive. So like that, we have measured values. We will also have errors with the measured values called as absolute errors. If you add up all these absolute errors and divide by the number of measured values, you are going to get something called as mean absolute error, guys. You are going to get something called as mean absolute error. So how will you write mean value? It is simply sigma I is equal to 1 to n ai divided by n. How will you find absolute error in any value, beta? Absolute error in ith value, if I say, it is mean value minus of ith value kept in magnitude. Then we also have mean of all the absolute errors. It will be given as sigma I is equal to 1 to n delta ai divided by number of measured values, guys. And whenever you want to represent any physical quantity, I will write it in terms of mean value and mean absolute error, guys. Whenever you try to represent a physical quantity, you will write it in terms of mean value as well as mean absolute error associated with it. Okay, some measured values will be given. Sum of all the measured values divided by the total number will give us mean value, right? So from the mean value, if you subtract the measured values, you will get absolute error in the measured values. If you add up all the measured values and divide by the total number of measurements, then you will get mean absolute error. So any physical quantity can be represented in terms of its mean value plus or minus mean absolute error, guys. Clear, all of you? Then we have something called as relative error. What is relative error given as? It is the ratio of mean absolute error to the mean value, guys. What we basically write it as? It is the ratio of mean absolute error to the mean value. And what is percentage error? Whenever we find out the percentage of relative error, that will be called as your percentage error. Four important things you should remember, guys, in case of errors again. Now, if you take any physical quantity, it will derived quantity. If I take, it will be obtained by using different quantities, guys. Yes or no? So different combinations we have. Let us say Z is one physical quantity. Again, I'll write it here only rather than. Okay. So if one quantity is obtained by performing addition of two quantities or subtraction of two quantities, then I will make use of mean absolute error beta. So mean absolute error in Z will be mean absolute error in A plus mean absolute error in B. Errors will always be added. Errors can also be subtracted, guys, but during the 11th 12th basic things, again we try to find out the maximum permissible error. That is the reason we simply add the error, guys. Clear, all of you? Whenever you are representing one physical quantity in terms of sum of two other quantities or difference of two other quantities, then I'm going to make use of the mean absolute error, guys. Mean absolute error in Z will be mean absolute error in A plus mean absolute error in B. In the same manner, when we represent it as product of two quantities or ratio of two quantities, then I will use relative error, guys. What is relative error? It is ratio of mean absolute error to the mean value. Should be equal to, what is mean relative error in A? Delta A mean divided by A mean. What is relative error in B? Delta B mean divided by B mean. And what will you do? You will simply add errors, guys. In the same manner, when one physical quantity is represented in terms of another physical quantity raised to some power. So in this case, what will you do? In this case, also you'll take relative error only, guys. Delta Z mean divided by Z mean will be equal to n times of delta A mean divided by A mean. Right? The second case and third case, if you add up, then I'm going to get different combinations again. Right? Suppose if I write Z value as A power M, B power N divided by C power some Q, guys. So I can also write it as A power M, B power N, C power minus Q. So it is a combination of multiplication, division, and raising to power, guys. So in this case also I'll use relative error. So delta Z mean divided by Z mean. What is relative error in A? It will be delta A mean divided by A mean. What is relative error in B? Delta B mean divided by B mean. What is relative error in C? Delta C mean divided by C mean. What should happen to errors? Errors should always be added, guys. Now, one very important thing that you need to know is the power of the physical quantity will become the coefficient. Power of A is M, here it becomes coefficient. Power of B is N, here it will become coefficient. Power of C is minus Q here, guys. While calculating error, you will take Q only. But if they ask you to find change, guys, then you will write it as it is again. You will write it what? As it is. If you want to find percentage error, you'll just multiply by 100 in all cases. Clear, everyone? Yes or no? These are the combinations of errors again, guys. Right? Whenever we measure a physical quantity, there will be some uncertainty. That uncertainty is only called as error. Okay. So how will you find error? In any physical quantity, any physical quantity will have true value. How to obtain true value? We'll perform experiment repeatedly and take down the measured values. Sum of all the measured values divided by total number of measurements will be your true value. Again, with every measured value, you will have an error. That error is called as absolute error. So from absolute error in all the measured values, we will be calculating the mean absolute error, guys. Right? So mean absolute error will be sum of all the absolute errors divided by the total number of measurements. Ratio of mean absolute error to the mean value will be called as relative error, and ratio of mean absolute error to the mean value into 100 will be your percentage error. Four different combinations of errors we have, where a physical quantity is represented in terms of sum or difference of two other quantities, where a physical quantity is represented as product of two quantities or ratio of two quantities, where a physical quantity is represented in terms of another quantity raised to some power. You say area of square, guys, it is L square. So area will be represented in terms of length raised to the power 2. Such cases again. Similarly, whenever a physical quantity is represented in terms of n number of physical quantities raised to some arbitrary powers, guys. So these are very, very important. And always remember, if you have a numerical constant value, a numerical constant value will not change, will not have any uncertainty. So with a numerical constant value, error will always be zero. There will not be any error in numerical constant values, guys. Clear, everyone? Yes or no? Right. So basic applications which repeatedly will be asked will be this, guys. Time period of simple pendulum. So time period will be proportional to L power 1 by 2. So is this third case or not? So because it is third case, I will directly use relative error. Delta T by T will be delta L by L. But what should happen to the power? Power should become coefficient. In the same manner, if you take finding the error in measurement of area or volume, as you can see, area of sphere is represented as 4 pi r square. 4 and pi are which values, beta? Constant values. Will there be any error in it? No. In the same manner, volume will be represented as 4 by 3 pi r cube, guys. So you can just take it something like this. The volume is represented as 4 by 3 pi r cube. Will there be any change in 4, 3 and pi? No change. So area will be proportional to r square. Volume will be proportional to r cube. So from there I will get delta A by A will be 2 times of delta r by r. Delta V by V will be 3 times of delta r by r. Clear all of in the same manner. If you are taking resistors in series, see, I am obtaining one resistor by using addition of two other quantities. So I'll make use of which error, beta? I'm just going to make use of mean absolute error. So delta Rs will be equal to delta R1 plus delta R2. However, parallel combination is very important, guys. We know in parallel combination, what is effective resistance given as 1 by R1 plus 1 by R2. So in order to find the error in the effective resistance, I will use delta R divided by R square will be delta R1 by R1 square plus delta R2 by R2 square. It's a very important case again. So in order to calculate error in the measurement of effective resistance in parallel combination, I'll write it as effective resistance square delta R1 divided by R1 square plus delta R2 divided by R2 square. And how will you get resistance in parallel? As R1 R2 divided by R1 plus R2 you can write. And always remember, if suppose whenever you are measuring, there will always be error. If in question, if error is not mentioned, guys, then we will consider least count of the measuring instrument to be as the error again. Length is measured by a scale. Length of 5 meters is being measured by a scale. Error in length is not mentioned in the statement. So what I'll do, I'll take least count of the scale as the error in the measurement of length, guys. So whenever error in a physical quantity is not mentioned in the question, what we will do, we will take the least count of the measuring instrument as the error in that particular physical quantity. I hope it is clear, all of you. Yes or no, everyone? If error in a physical quantity is not mentioned in the question, what will you do? You will choose the least count of the measuring instrument as the error in that particular quantity. I hope it is clear. Right. If we talk about vernier calipers, basic questions will be asked. We will see the application. We will see all these through applications, guys. So it will consist of two scales again. One will be main scale, other will be vernier scale. Main scale is simply your ruler, guys. Ruler again. So what will be one division? one main scale division. It means one division on main scale will be 1 mm, guys, or 0.1 centimeters you can consider. What is the principle involved in vernier caliper? If I say again, always remember n vernier scale divisions. This is the principle involved. It is not given here. N vernier scale divisions will coincide with n minus 1 main scale divisions. And what will least count be given as? Whether it is a normal caliper or an abnormal caliper, the least count will always be given as 1 main scale division divided by, sorry, minus 1 vernier scale division. Clear, all of you? These three things you should be aware again, right? Four formulas that you need to know. First one will be, what is each division on main scale equal to? Will be equal to 1 mm. Then what is the principle of working of a vernier caliper? N vernier scale divisions will usually coincide with n minus 1 main scale divisions. And least count formula will be given as 1 main scale division minus 1 vernier scale division. I can also write least count value as 1 main scale division divided by number of divisions on the vernier scale. Usually you will have 10 divisions of vernier scale and one main scale division will be 1 mm. So least count for a normal vernier caliper, if I take, it will be 0.1 mm or 0.01 centimeters. See, 20 divisions on vernier scale will usually coincide with 19 divisions on main scale. If such type of statement is given, then it is a normal vernier caliper. And for normal vernier caliper, you can write least count as 1 main scale division divided by total number of divisions on vernier scale. So usually, how many divisions will be there on vernier scale? There will be 10 divisions, guys. In general, there will be 10 divisions on vernier scale. So what would be least count of a normal vernier caliper? It will be 0.1 mm or 0.01 centimeters. Sometimes they'll give you, so in reality, 20 divisions on vernier scale should coincide with how many divisions on main scale? 19 divisions. That will be a normal vernier caliper, guys. However, if 20 divisions on vernier scale are coinciding with 18 divisions, then it will be a abnormal vernier caliper. Again, in reality, there is no term called as, a normal vernier caliper or abnormal vernier caliper. Just to make you understand, I am using those terms, guys. 20 divisions on vernier scale, if they are coinciding with 19 divisions on main scale, a normal caliper, right? 20 divisions on vernier scale, if they are coinciding with 12 divisions on main scale, or 15 divisions, or 18 divisions, or 21 divisions, or 22 divisions, then such type of caliper will be a abnormal caliper. Whether it is a normal caliper or a abnormal caliper, least count formula will remain same, guys. 1 main scale division minus 1 vernier scale division. This formula, however, is true only for a normal vernier caliper. Clear, all of you? Yes or no? Then we also have something called as the actual reading, guys. So whenever we talk about actual reading, the actual reading using a vernier caliper can be given as main scale reading plus least count into vernier coincidence, guys. Right? So these four formulas you should, three formulas you should remember again in case of your vernier caliper. In the same manner, you have screw gauge. When I talk about screw gauge, guys, right? It also has two scales, just like vernier caliper. You have a main scale, but in place of vernier scale, here you have a rotating circular scale. There in vernier scale, we have 10 divisions generally. Here in circular scale, you will have 100 divisions, guys. Right? So what we'll write again in this situation, least count value, if I consider, it is directly 1 main scale division divided by number of divisions on circular scale. It is also given as pitch of the screw gauge divided by number of divisions. It's a very, very important formula, guys. Pitch was given in 2020. So least count of a screw gauge will be given as 1 main scale division divided by n. So what is n here? Usually 100 again. And how many divisions will be there, beta, on circular scale? In general, you will have 100 divisions on circular scale. So I can say least count of screw gauge will be 0.01 mm or 0.001 centimeter again. Or least count can also be given as pitch divided by number of divisions on the which scale, beta? On your rotating circular scale. In the same manner, Here, in case of your screw gauge, the actual reading beta, it will be given as main scale reading plus least count into circular scale reading, or you can say circular scale division also, guys. This is how you give the main scale reading in case of your screw gauge. So these things you should know. You'll also have one term called as zero error, guys. However, related to zero error, we will see with the questions again. So some basic dimensions are given. It's not necessary to know the dimensions always. As I said before also, if you know the formulae of that particular physical quantity, you will be able to get the dimensions within seconds, guys. So majorly questions from this chapter will come from either dimensions, how to perform dimension analysis, and some equation may be given. The questions which we'll do, questions may come from errors, question may come from measuring instruments, either a vernier caliper or screw gauge. Basic formulas you need to know. With zero error, I'll tell you in application part. Questions may come from rules for arithmetic operations. Right? Majorly, these are the areas where questions can be asked from this particular chapter, guys. Clear, all of you? Yes or no? Some dimensions are there. Again, it's not necessary to know the dimensions, right? Right? You got magnetic permeability last time, I guess, and you also got one match the following, guys, based on dimensions of gravitation. You got right around four questions you got again from dimensions, from units and measurement. Okay, one I can consider that to be from gravitation only, but still, because dimensions were the concept, so you can say four questions we got in last year exam, guys. Clear, all of you? Yes or no, everyone? Now, just before the beginning of the session, I've told you that giving review and solving questions for the next chapters may not be possible, guys. So, for the next chapters, which are modern physics and heat, we will solve questions. However, as I have shared the notes of the brief notes of the all the chapters that I've explained till now, the same way I'll be sharing the brief notes of modern physics as well as heat as well. Okay, so please go through that. That would be very much helpful again. So on that note, we will just quickly move on to the questions of units and measurement, whatever are possible, right, till 9:15, 9:30, or for the next 1 hour. We will just complete solving them, guys. I've already shared the test. Please do write the test. I'm observing that the number of people who have written the test has come down from 11, 12 to only 2 people, guys, which is not good at all. Just give me a minute, guys. Am I audible, everyone? Am I audible, all of you?
Yes, sir.
Yeah, some people have sent me questions. I'm really sorry. I'm just, I'm not able to send you the solutions of that, right? Because I don't know, in some or the other work, I'm being occupied and I'm not able to share the solutions. Hopefully, I'll see. Right. If A, B, C are three physical quantities such that A and B are of same dimensions, while C has different dimension, then which of the following may be meaningful, they are saying. C has different dimensions compared to A and B. Can A and C be added, guys? Certainly not. Right? Can B and C be added? Certainly not. Right? Can C and B be added? See, if you multiply, length is 2 meters, B let us assume is length, C let us say is temperature. So B is 2 meters. 2 times of 2 meters will be 4 meters again. This will anyhow be meter. This will be temperature only. So can temperature and length be added? No. So what is the possible answer for this? 2a minus 3b divided by c would be the possible answer. As I said, what is the basic rule? Addition, subtraction, comparison can be done, right, with physical quantities of same dimensions. Multiplication, division can be done with physical quantities, can be done with physical quantities of any dimensions, guys. Next case, if I see time period of a simple pendulum are recorded again, something in this manner. All this we can understand. See, three measured values are given. So what we can tell regarding mean value of the simple pendulum beta? देखो directly 1.9 plus 2.0 plus 2.1. Three measured values are there divided by 3. So how much will I get? 2, 2.1 is 4.1. You will get it as 6.0 divided by 3. Will this be 2.0 or not? So 2 seconds will be our mean value. Now, what is mean absolute error in first measurement? So delta T1, what will it be? Magnitude of mean value minus first measured value. Magnitude again only, guys. So what will I get? I'll get it as 2 minus 1.9. How much will this be, beta? 0.1. What will be absolute error in second measured value? Again, magnitude of mean value. It will be magnitude of difference of mean value and the second measured value. How much is it? 2.0 minus 2.0. There is no difference, so you'll get 0. What is absolute error in the measurement of third value? It is magnitude of mean value minus third value, which is 2.0 minus 2.1. Magnitude only, guys. So you'll get inside, you'll get minus 0.1, but anyhow, overall, you'll get it as 0.1. So what is the mean absolute error? If we talk about mean absolute error, it is sum of all the absolute errors. What are those? 0.1 plus 0 plus 0.1 divided by what are we going to get? Number of measured values, which is 3. So I'll get it as 0.2 divided by 3, guys. So how I can write it as? It will become 0.0666 you can write, or 6667 you can write. Now, all the measured values are read up to one decimal place only, guys. So I should take it up to one decimal place. So you'll just keep on rounding off. If you round off 6 here, you'll get 0.67. If you round off 7, you'll get 0.07. If you round off 7, what will this be, beta? You'll get it as 0.1 second. Right? So what is the mean absolute error here? 0.1 second will be the mean absolute error, guys. Is that clear, all of you? Yes or no? Right. Then relative error they are asking. What is relative error? It is mean absolute error divided by the mean value. So what is mean absolute error here? 0.1 divided by 2, 2.2. So I can write it as, this we can write it as 0.05 second. Relative error will not have any units, guys. It will not have any dimension also. 0.05 will be the relative error. So if we talk about percentage error, guys, what is percentage error? It is the relative error into the mean, into 100. Yes or no? So 0.05 into 100, how much is it going to be? 0.05 into 100 if I take, you will get this as 5%. So which out of them is true, guys? Is mean absolute error 0.01? Mean absolute error will have units. Is mean absolute error 0.01 second? No, it is not 0.01 second. Is relative error 0.05? Yes, relative error is 0.05. Is percentage error 0.5%? No. Is percentage 0.05%? No. It is how much? 5%. So So whenever we, and if I want to represent the time period, how will I represent beta? Mean value of, if I want to represent the time period, simply t if I want to represent. So I will write first mean value 2 plus or minus mean absolute error 0.1 seconds. This will be the time period. This is how you solve questions. You take any quantity, guys, measured values will be given. You can represent mean value something like this. Find absolute error in each measured value. Then find out the mean absolute error. Then you can find out relative error. Then you can find out percentage error. And how will you represent the physical quantity? Mean value of the physical quantity plus or minus mean absolute error associated with it. I hope it is clear. Yes or no? What did they give, guys? They have given us epsilon naught is permittivity of free space. Mu naught is magnetic permeability of free space. What is the dimensional formula? 2 divided by mu naught epsilon naught. What they have given? This they are asking. 2 divided by mu naught epsilon naught whole power 1 by 2. Can I write it as root 2 divided by root over mu naught epsilon naught? So I can write it as root 2 into 1 by root over mu naught epsilon naught. What is this? Root over 1 by root over mu naught epsilon naught is nothing but c beta. So whatever physical quantity is, it is nothing but speed of light. Root 2 is a numerical constant. So does it have any dimensions? Root 2 is numerical constant only, no? It is dimensionless. What will be dimensions of c? Because it is your velocity, we can write m naught L power 1 t power minus 1. So m naught L power 1 t power minus 1 will be your answer. 1 by root over mu naught epsilon naught is nothing but your speed of light in vacuum, guys. Root 2 is a numerical constant. So will it have any dimensions? No. C is speed of light. What will be dimensions of speed of light? L t power minus 1. Clear, everyone? So you see a particle moving on a straight line has initial velocity 2.03, accelerating uniformly with 1.03. After 0.3 seconds, what will its velocity be? Uniform acceleration is there. So can I apply v bar is equal to u bar plus a bar into t or not? I don't know the final velocity. They're asking us to find final velocity. What is initial velocity? 2.03 plus. Here you have acceleration is given as 1.0 and 0.3 seconds. Very important, guys. See, this is one physical quantity. This is another physical quantity. What are we doing to these two physical quantities? Are we multiplying or not? Yes or no, beta? So whenever you are multiplying two physical quantities, what do you need to retain? You need to retain significant figures. How many? Least number. So please tell me how many significant figures are there in this? You have two significant figures in this, guys. How many significant figures are there in this? You have one significant figure. So how many you need to retain, beta? You need to retain only one. So if I multiply 1 with 0.3, I'll get it as how much, beta? 0.3 only. How many significant figures are there in this? You have one only. Okay. Now you see, you have two physical quantities. This is one quantity, this is another quantity. What is being done to these two quantities? These are being added. Whenever two quantities are being added, what you should retain? Decimal places. How many? Least number. So if I just add both of them, what will I get? 2.33 I will get. But this has how many decimal places? Two decimal places. But how many I need to retain? Only one decimal place, guys. So for that reason, what are we going to do? We are going to drop off this insignificant digit. Because it is less than 5. Are we going to make any change in the previous value? No, guys. So our answer will remain 2.3 itself. Clear, everyone? Yes or no? Whenever you are multiplying, dividing, retain significant figures. How many? Least number. Whenever you are adding, subtracting, retain decimal places. How many? Least number. Clear, all of you? Yes or no, yaar? Then they have given us a physical quantity x, which is represented something in this manner, right? So I can write x value as, I'm just making it like this, guys, alpha square beta cube Here root over rho is there. So can I write rho power minus 1 by 2 and gamma power minus 3 by 2 or not? So which combination will it be, guys? Final combination, where one quantity is expressed in terms of different quantities, right, raised to some different powers, guys. So I'm going to make use of which error? Relative error. What is relative error in x? Delta x by x. What is relative error in alpha? Delta alpha by alpha. Relative error in beta? Delta beta by beta. Relative error in rho? Delta rho by rho. Relative error in gamma? Delta gamma by gamma. What should happen to errors? Should always be added. Because they're asking errors, power should become coefficients. 2, 3. Here you have minus 1 by 2. While calculation of errors, guys, whether you have positive power or negative power, you will take only positive values. Here you have minus 3 by 2, I will take only 3 by 2. They're asking us to find percentage error in x beta. So if I just do percentage error, I'll get 2 times of delta alpha by alpha into 100 plus 3 times of delta beta by beta into 100 plus half times of delta rho by rho into 100 plus 3 by 2 times of delta gamma divided by gamma into 100. So already what are percentage errors given? For uh, alpha it is given as half, for beta it is given as 1 by 3, for rho it is given as 2, for gamma it is given as 1 by 3. So what we can cancel out? So here you will have 1%, here you will have 1%, 2%, 3%, and 1 by 2. So you are going to get it as 3.5%. Clear, everyone? This is how you will solve errors question again. Very important concept, very important question also. Understood, everyone? Hope you understood. Right. Let us see the next question. If power of a force P is given as power of a force varies with displacement, something like this. They're asking what are the dimensions of A and B. So how will you do this question? Very simple, guys. P is power here, ax square divided by b minus 2t. So you look at denominator first. I have two quantities in denominator which are being subtracted. So from this, what conclusion can I make when two quantities are being subtracted? Their dimension should be same or not. So dimensions of b will be equal to dimensions of 2t. 2 is a numerical value. It doesn't have any dimensions. So always remember, by convention, dimensionless will numerical constant will be dimensionless, and dimensionless quantities can be written as simply 1, guys. So I can write from this dimensions of b will be equal to, I'll write it as dimensions of 2 into dimensions of t. Will 2 have any dimensions? No, I'll simply write it as 1. So what are we going to get dimensions of b as? Dimensions of b, I will get it as dimensions of t, which will be nothing but capital T. Okay, first thing we have calculated. Next, then you see beta. Left hand side, I have one equation, one quantity called as power. Right hand side, I have one big quantity ax square divided by b minus 2t. Now, left hand and right hand both are equal. When will they be? When can two physical quantities be equal? In order to define a physical quantity, we need to know its numerical value and unit. If two physical quantities are equal, definitely their numerical value will be same as well as units will be same. If units are same, then automatically dimensions will be same, guys. So what I can write here, dimensions of P will be equal to dimensions of ax square divided by b minus 2t. See, suppose if this anyhow is time, this is automatically again going to be time only or not. So I can write it as dimensions of ax square divided by b, I can write, or I can write it as dimensions of ax square divided by 2t also I can write. Power is basically represented as force into velocity, guys. So if I do that, I'll get it as ml square t power minus 3 should be equal to, I don't know dimensions of a, I can write dimensions of x square divided by dimensions of b. So from this, what are we going to obtain? ml square t power minus 3 will be equal to, what are dimensions of a I need to find? X is what beta? Displacement. Displacement is measure of length. So displacement will have dimensions L, displacement square will have L square. B has dimensions of t again. Just now we have got. So what will be dimensions of A beta? You will get it as m L naught t power minus 2. They are asking us to calculate what are dimensions of A and B, guys. A into B. So what will be dimensions of A into B? It will be dimensions of A into dimensions of B. What did I get dimensions of A as? I got it as m L naught t power minus 2. B dimensions we got it as t, guys. So I can write dimensions as m L naught t power minus 1 will be the dimensions of your A into B. M L naught t power minus 1, fourth option will be the answer, guys. Clear, everyone? Yes or no? I hope it is clear. Right. Next question, you see, force, acceleration, time are considered to be fundamental quantities. What is dimensional formula of surface tension they are asking, guys? So I want to represent what? Surface tension. In terms of what? Force, acceleration and time. What will I do, beta? Whichever quantity is asked to be represented, surface tension is asked to be represented, I have taken it at left hand side. Should be equal to, in whose terms I need to represent? Force, acceleration and time. So I'll raise them to some arbitrary powers x, y and z. Now what I'll do, beta? I'll substitute these dimensions again. Surface tension is nothing but force per unit length, guys. So I can write it as m L naught t power minus 2. Force is what? M L t power minus 2 whole power x. A is acceleration, so I can write L t power minus 2 whole power y. T is time, I can write t power z. So what I'll get? M is raised to the power 1, L naught t power minus 2. Left hand side direct things I'm writing is I'll get m power x, L power x plus y, I'll get t power minus 2x minus 2y plus z I'm going to get. So what are we going to do now? Again, bases you see are same and both are separated by equal to sign. So automatically power should also be same. What is the power of x? Power of x if you considered, sorry, power of mass if you considered on right hand side it is x. On left hand side it is 1. Power of length you see beta, you got x plus y. Length on left hand side is 0. So from this I'll get y value as minus 1. Then power of time minus 2x minus 2y plus z. Power of time on left hand side is minus 2. From this what are we going to get? This will be minus 2. This will get it as plus 2. So z value again I'll get it as minus 2 only, guys. So I got the values, x value we got 1, y value we got minus 1, z value we got minus 2. So finally, how can I represent surface tension? It is force raised to the power x, which we got 1. Acceleration raised to the power y, which we got minus 1. And time raised to the power z, which we got minus 2. So F1, a power minus 1 and t power minus 2 will be your correct expression for surface tension in terms of force, acceleration and time. F power 1, a power minus 1, t power minus 2. Third one will be the correct explanation, guys. Clear all of you? Understood, everyone? Right. So next question, if you see, they are asking us, if each division on main scale is 1 mm, which of the following vernier scales gives vernier constant equal to 0.05 mm, it seems. Right. 9 mm divided into 10 divisions, 19 mm divided into 20 divisions. Vernier constant, they are saying vernier constant equal to 0.05 mm. So vernier constant here, I think, is also given as least count, guys. Vernier constant is also given by least count. So what will you do? Very simple logic. How to find such type of question, guys? Very simple logic. I'll just tell you here. 9 mm divided into 100 divisions. So what will be each division? Each division on vernier scale again it is. So if I take 9 divisions, 9 mm divided into 10 divisions. So in first case, what will be one division, beta? One division on vernier scale it is. One division will be 0.9 mm. Yes or no? In second case, what will be one division? One division, I will get it as 19 by 20 mm again. So 19 by 20 will be how much, beta? 19 by 20, if I say it is 1.9 divided by 2. So 0.95 mm you will get. Third case, what will be one division? it will be 90 divided by 100. So I'm going to get again 0.9 mm. In fourth case, what will be one division? 99 mm is divided into 100 divisions. So what will one division be, guys? It will be 0.99 mm. So what are these values? These are all vernier scale divisions. Whether it is a normal caliper or abnormal caliper, what is least count value given us? So these all values are what, beta? These all values are your vernier scale divisions. So vernier constant is nothing but least count here. What is the formula for least count? Least count will always be 1 main scale division minus 1 vernier scale division. And all these are the values of vernier scale divisions, guys. So in first case, you please tell me what will be least count? It will be 1 mm minus 0.9 mm. Will I get it as 0.1 mm or not? In second case, you see, what will be least count? 1 mm minus 0.95 mm. Will I get 0.05 mm or not? In third case, you see, beta, what will be least count be? Again, it will be 0.1 mm only. And in fourth case, what will be the value of least count? It will be 0.01 mm. They are asking us in which case will vernier constant value be 0.05 mm. So in which case will it be, beta? In second case, you are going to have 0.05 mm. Is that clear, all of you? Yes or no? I hope it is clear, right? Because if you see the dimensional formula they are asking of a physical quantity is m power a, l power b, t power c. What is the physical quantity? M power 1, b power 2, c power minus 1. It is torque. No, guys. Torque will be m power 1, l power 2, and t power minus 2. So this is wrong. Torque is force into distance, you can write, guys. Force is ml t power minus 2 into L. If you do, you'll get ml square t power minus 2. Surface tension, just now we have done, it is m t power minus 2. So here we are getting m power 1, L power 1, c power minus t power minus 2. Will that be correct? No. Impulse is force into time, guys. Force is ml t power minus 2. If you do into time, I'll get ml t power minus 1. You see, m power 1, L power 1, t power minus 1. This will be correct, guys. Acceleration is what? L t power minus 2. So you got m power 0, L we got, but t power minus 1 we are getting. This is also wrong, guys. So impulse will be correct. Which of the following is more precise instrument, it seems? Which one will be more precise, guys? Whichever has a lesser least count will be more precise. Okay. So what is the situation here? Meter scale has smallest division of 1 mm. Always remember what is the meaning of least count, right? It is the smallest value that can be directly taken from a measuring instrument. So smallest division is 1 mm means what will be least count of the main scale of the meter scale here? 1 mm. In second case, you see, beta, vernier calipers in which 20 vernier scale divisions are coinciding with 19 main scale divisions. Please tell me, is it a normal vernier caliper or abnormal vernier caliper? It's a normal one only, yes or no? Why? Because n vernier scale divisions are coinciding with n minus 1. So in that case, what will be least count? I can directly write 1 main scale division divided by n, which is here 1 mm divided by number of divisions is 20. You'll get it as 0.05 mm, beta. Third case, you see, screw gauge of 0.5 mm smallest division on linear scale. So again, for screw gauge also I can write 1 main scale division divided by number of divisions on circular scale. Here it is given as 0.5 divided by 50, guys. So what I'll get? I'll get it as 0.01 mm, guys. Yes or no? 0.5 mm by 50 will be 0.05 by 5, which is 0.01 mm. And what is this vernier caliper of least count? 0.02 is given. Which one has, right, which is very, very less value, guys? Out of all these, which one has lesser value of least count? Which quantity, in which case do you have very less value of least count? In third case, do we have less value of least count or not? So third one will be your more precise measurement, guys, or more precise instrument. Understood, all of you? Is that clear? Whichever, again, if I say in terms of decimal places, Whichever quantity has more decimal places will be more precise again. You can use that concept also again. So however here I got three quantities to have same number of decimal places. So these three can be equally precise, but out of these three I'll take the least value guys, which is for screw gauge again. Understood all of you? Who among the following scientists was awarded Nobel Prize for his work on photoelectric effect? Who gave photoelectric effect? We'll study in tomorrow session again. Einstein's photoelectric effect we got. However, Einstein didn't get for the famous equation E equal to mc square. He got the photoelectric effect for, he got the Nobel Prize for photoelectric effect, guys. Clear all of you? And you see, next question, if you observe, guys, a system has units, a system of units has 10 kg, 10 centimeters, 10 seconds as the units of mass, length, and time. And the value of 10 Newton in this system will be how much they're asking. Okay, so what we can write here, beta? So what is 1 Newton basically? What is 1 Newton? If I write, it is 1 kg, 1 meter per 1 second square. Yes or no? This is 1 Newton again. So what is mass here? Is it 10 times or not? So it's a basic way of doing it, guys. They're asking us what is the value of 10 Newton in this system. So what I'll do, I'll write units has to remain same, no? So 10 Newton, if they are saying, so it is represented as what? 10 kg, 10 centimeter. So, or we'll do in easiest method, guys, which I feel easy. I'll just let you people know. So, in general, what is 1 Newton? It is 1 kg meter per second square. So, here in place of 1 kg, what do we have, beta? We have 10 kg. Yes or no? In case of 1 meter, I have 10 centimeters. 10 centimeters is 0.1 meter. In case of 1 second, I have 10 seconds, guys. So 10 seconds means I'll write 100 seconds square. So what I'll get this value as 1 by 100 of kg, sorry, 1 by 1000 you will get. 1 by 1000 kg meter per second square. This is your 1 Newton. So it is 1 by 1000 times. They're asking what, guys? How much will be 10 Newton? So what will 10 Newton be, guys? I can write it as, if I multiply by 10, I'll get 1 by 100 kg meter per second square. So it will be how many times? It will be 100 units, guys. It will be 100 units. Clear all of you? Yes or no? It will become how many units? 100 units. So whenever you are doing in this way, you can solve it in this particular method, guys. Clear all of you?
Sir, isn't it 1 by 100, sir? So
No, no,
what
no,
is it?
no. When again, there are different ways of doing. So this I created it just because we are getting the answer easily. 1 Newton, we basically, this is in actual unit, 1 kg meter per second square. In new unit, what is 1 kg here? 10 units. What is 1 meter? 0.1 units. What is second? 100 units. So I'll get 1 by 1000 here. So this will become 100 times in the new system. Whenever you are doing in this method, you can directly write it as 1 by 100 times. It is not becoming 1 by 100 times, it becomes 100 units again.
Clear, sir.
Why? Because we write 1 kg meter per second square in our old unit as x y by z square. Means x kg in new unit, right? Y meter in new unit divided by z second square in the new unit. Okay, so what I got x value here? You can write 10. What is y value? You'll get 0.1. What is z value? You will get it as how much? 10 square. Now I'll get kg meter per second square here. So what will this be? We'll get it as 1 by 100 kg meter per second. But what is kg meter per second square? It is 1 Newton again. In 1 Newton in new system of unit will be 100 units in the other case. Okay, that is how we solve it basically. 1000 I think you will get over here. Whatever it is, just check it, guys. Huh? We got 1 by 100, no, here? How did I get 1 by 1000? 1 by 100 only I'll get, no? So 10 units will be 1 by 10 over here. So it will be 10 units here, guys. The new system, it will be 10 units.
So did you just multiply it or did you just divide it?
Which one I have multiplied?
So after getting 1/1000 as for 1 Newton.
We should not get 1/1000 there. Here we'll get 1/100.
Okay, yes.
So this is our new Newton. So this new Newton is how many units? 100 units in the old Newton. Okay. So what will be 10 Newton they are asking? So that would be 10 units again. Clear?
Yes, sir.
Just remember, n into u will remain constant. Numerical value into unit will remain constant. Let's see next case. Two quantities are measured. What is the correct value of root AB? So A is given as 1.0 meter plus or minus 0.2 meter. So from this, what I can say, beta? This 1 meter is our mean value of A. And 0.2 meters is our mean absolute error in the measurement of A. Similarly, B is given as 2.0 meter plus or minus 0.2 meter. So in this also, what we can write? I can write 2.0 meter will be mean value of B and 0.2 meter will be mean absolute error in the measurement of B. They're asking us root AB. So if I just want to find the value of root AB, some quantity, let us say it is Z. Mean value, if I want to find, what will I get? 1 into, you will get 2, which will be root 2, which I'll get it as 1.414. You see, this is correct to one decimal place, correct to one decimal place. So here also should get correct to one decimal place, which will be 1.4 meters. This is the actual mean value, but I should also calculate the error associated with it. So what will I do? Z can be represented as a power 1 by 2, b power 1 by 2. So here it is again fourth combination where one quantity is represented in terms of other quantities raised to some arbitrary powers, guys. I'll make use of relative error. Delta Z by Z will be delta A by A plus delta B by B. But what is the condition here? The power will become the coefficient, guys. So what we can write? Half into what is delta A value? 0.2. What is A value? 1 plus half into what is delta B value? 0.2. What is B value? 2. So what will I get this as? This I'll get it as 0.1 plus I'll get it as 0.05. So delta Z by Z value, I'm getting it as how much, beta? I'm getting it as 0.15. 0.15 meters I'm getting. Now what I'll do? I'll just multiply it with this. So I want to find delta Z value here. So what are we going to get delta Z value as? 0.15 into what is Z value, beta? 1.4. So if you just solve for this, you will get some value again. Right, so how will you represent the correct value as 1.4 meters plus or minus? How much will this be, guys? 14 15. How much are you going to get? 196 is 14 square. Yes or no? Will you get it as 2? Yes or no? So I think you'll get it as 0.2, I guess. 15 square is 225, no, yaar? So I can write it as 1.5 into 1.4. 1.5 into 1.4 will be 2. So you'll get this as 0.2 beta. So our answer should be 1.4 plus or minus 0.2 meters. Clear? 1.4 plus or minus 0.2 meters should be the answer for this. Total number of insignificant zeros they are saying, guys. How many number of insignificant zeros are we going to have? Right. It is a number less than 1. So all zeros before first non-zero digit. 3 zeros will be insignificant. As well, if you talk about this zero, it is a trailing zero with decimal point. So it will be significant, guys. So this will be your significant zero. All these 3 will be your insignificant zeros, guys. Okay, so how many insignificant zeros we have? 3. How many significant zeros are there? 1. Overall, how many significant figures are there? 4 will be the number of significant figures. Clear, all of you? Yes or no, everyone? I think you can solve this question now. Because of time constraint, I'm not discussing it, guys. How to solve it? I hope you can do it. Yes or no? In the same manner, I hope you can also do this also. They're asking to represent Young's modulus. So Young's modulus should be written as velocity, mass, time. Will you simply write velocity, mass, time? No. You will raise them to some arbitrary powers A, B, and C. Young's modulus of elasticity is nothing but stress by strain, guys. They will have same dimensions as pressure. ml power minus 1, t power minus 2 will be. Velocity is what? lt power minus 1 raised to the power A. M is mass, m raised to the power B. T is time raised to the power C. So what are we going to get beta from this? You can directly write. So what we can write from this situation? I can write m power B, L power A. So I think you can find out the situation or not. So here we have m, L power minus 1, T power minus 2. And on the right hand side, what I can write? I can write it as m power B, L power A, T power minus A plus C. So I'll just equate their powers now. So A value, I'll get it as minus 1. B value, I'll get it as 1. Minus A plus C value, I'll get it as minus 2. Implies I'll get C value as, this is minus 1. This is plus 1 again. If I send it on the other side, it will become minus 1. C value will be minus 3 again. So what will you write Young's modulus as? V to the power minus 1, m to the power 1, t to the power minus 3. V minus 1, m to the power 1, t power minus 3 should be the answer for that. Clear? Third option you will get. So whenever they're asking you to find dimensions of any physical quantity in terms of other physical quantities, whichever quantity's dimensions you need to find, that quantity will be taken on left hand side. In whosever terms you need to write, you will take those in right hand side and raise them to some arbitrary powers. Then you will substitute the dimensions in the second step, find the values of the variables. In the last step, you will write y value as v power minus 1, m power 1, and t power minus 3. Clear, all of you? Which one is most precise also you can do, because we have done just now. Whichever has least value of the least count, that will be more precise one, guys. I hope you can solve for it, everyone. I hope so. A weighing machine provides. Can you also do this? Just now we have done first question was based on time period. So can we solve this? 4 measured values are given. So can you find out the mean value? Yes. Can you find absolute errors in each measured value? Yes. Can you find the mean absolute error? Yes. Can you find relative error? Yes. Relative error and fractional error, both same, guys. Can you find percentage error? Yes, you can do that also. Clear, all of you? Right? Phenomena of scattering of light by change in wavelength. Who gave it, guys? It is Raman's effect again. Choose the correct statement among the following, it seems. Dimensionless quantity can have a unit. Is it correct statement? Yes or no? Unitless, definitely dimensionless. But dimensionless can have a unit. It is a correct statement, guys. A dimensionally correct equation must be correct, it seems. Not necessary again. Physically correct equation is always correct. Dimensionally correct equation need not be correct, guys. This is wrong statement. Change in the system of units will surely change the numerical value of the physical quantity. Not necessary again. It is not necessarily going to change. Dimensions of physical quantity can never be a fraction. They can be a fraction. No? T power something also we can write. That's not a big deal. So dimensionless quantity can have a unit is the correct among the 4 statements that have been given, guys. This also I think you can do a by b. Similar question. Just now we have done ax square divided by b minus 2t. We did no in the same manner. But their power was given here. What is given? Linear momentum is given. So very basic logic. What will you do, beta? Dimensions of b and dimensions of 3x will be same. So I can write dimensions of b as dimensions of 3 into dimensions of x. 3 is a numerical constant, doesn't have any dimension. So dimensions of b will be L. And I also write dimensions of p will be dimensions of a root x divided by b plus 3x. I can also write it as dimensions of a root x divided by b, or I can write it as dimensions of a root x divided by 3x, guys. So from here we can find dimensions of a also. And you can calculate the dimensions of a by b. Clear, all of you? Yes or no? Whenever addition or subtraction is done, same dimensions. Multiplication division is done, it can be done with different dimensions also. Clear all of you? What is surface tension in SI unit? It is Newton per meter, guys. This is an SI unit. So how can I write it in CGS unit, guys? 1 Newton is 10 power 5 dyne, and 1 meter is 100 centimeters, guys. So I can also write it as 10 cube dyne per centimeter. So in CGS unit, P value is 1. Sorry, in SI unit. So in CGS unit, what will its numerical value be? It is 10 cube. They're asking P by Q value, which you will get it as 1 by 10 cube, guys. Okay, 1 by 10 cube can be written as 10 power minus 3 is to 1. Can you do in the same manner this also or not, guys? So ml square t power minus 1 will be dimensions of angular momentum. Angular momentum will have same dimensions as that of Planck's constant. So both are true, guys. So both 1 and 2 will be true. However, this will be m power 1, L power minus 1, t power minus 2 you should get. So here r is t is raised to the power 1, which is wrong. So angular momentum and Planck's constant will have same dimensions. Dimensions will be m L square t power minus 1. So if you substitute P, Q and R, you will get the same thing again, guys. Clear, everyone? What would be order of magnitude they are asking? Whenever we consider order of magnitude, 192 is given. So I can write it as 1.92 into 10 square. So whenever a quantity is written in the form of a into 10 power b, guys, always remember two things are possible. If a value is less than or equal to 5, then b will be order of magnitude. If a value is greater than 5, then b plus 1 will be order of magnitude. So here I wrote it as less than 5 only I've written. So what will be the order of magnitude in this case? 2 will be the order of magnitude. Clear, everyone? We got a good question based on screw gauge. Let us try doing that particular question, guys. Pitch of a screw gauge is given as 1 mm with 100 divisions on circular scale. So what is given to us? Pitch is given as 1 mm, and what are number of divisions given as 100, guys. In measurement of thickness of a wire, there are 3 divisions on linear scale. Right? Means each division, linear scale is nothing but main scale. It's just like a ruler, guys. So what I will get main scale reading, it will be equal to 3 divisions on main scale. So what is the meaning of 3 divisions on main scale? These are 3 main scale divisions. Each division on main scale, each division on ruler will be 1 mm, guys. The main scale reading here will be 3 mm. From these two, pitch and number of divisions, can I calculate least count? Yes. What is least count going to be? Least count value will be given as pitch divided by number of divisions, which is 1 divided by 100. You will get it as 0.01 mm, guys. Then what they have mentioned, 25 divisions on circular scale coinciding with reference line. So here the circular scale reading happens to be 25, guys. Now, if nothing is put between the studs, 20th division on circular scale is coinciding. So it means the 0 will be lying above here, guys. So always remember, we'll have something like this. So suppose till here, if I just solve the question till here, without 0 error, our reading, if I take, guys, the actual reading now, without 0 error, here 0 error is given, guys. So actual reading, what will I get? It is main scale reading plus least count into circular scale reading. Yes or no? So what is main scale reading here now? Main scale reading is given as 3 mm. What is least count beta? You got 0.01. What is circular scale reading? We got 25. So I'll get it as 3.25 mm. Yes or no? But what they have given, if nothing is put between the studs, then 20th division on circular scale. See, this is our reference line. This is our circular scale, guys. Always remember, when 0 of circular scale exactly coincides with reference line, there will not be any zero error, guys. No zero error in this case. However, if I take when 0 of circular scale is lying above the reference line, right? So in this case, you are going to have your negative zero error, guys. You will have negative zero error. Okay, in the same manner, right? If the 0 of circular scale is lying below the reference line, then in this situation, I'm going to get positive zero error, guys. I'm going to get what? Positive zero error. Now, what they are saying, if nothing is put, so when will I get 3.25? I'll get 3.25 mm as the answer with no zero error. So here, obviously, zero error is there. If nothing is put between the studs, the 0 and reference line should coincide with each other, guys. But here, are they coinciding? No. If 20th division on circular scale is coinciding with the reference line such that 0 of linear scale is visible, then what is the thickness of the wire they are saying? So 20th division is coinciding here. So in this situation, it will have positive zero error. So 0 will be here, then followed by 5, 10, 15, 20. So here you have positive zero error. So now what will actual reading be? If zero error is there, guys, then actual reading will be given as main scale reading plus least count into circular scale reading or circular scale division plus zero correction. And what will zero correction be? The zero correction will always be minus of zero error, beta. What will zero correction be? It will always be negative of zero error. It is always going to be negative of zero error. So this will be the reading without a zero error, guys. This will be the reading without zero error. Same will be the case in your vernier caliper also. And this will be the reading with a zero error. Whenever zero error is there will always be some correction, guys. And that zero correction should be minus of zero error. Now you please try to understand. Zero is there, guys. You usually wrote it in anti-clockwise sense again. The 5 will be present above 10, 15, 20 like that. So here 20th division is coinciding. So it means which error we have? Positive zero. So what will be correction? Negative, guys. So what are we going to get? How this value we already got it as 3.25 mm plus negative correction we are going to get means minus of 0.20 I'll get, which will be how much, guys? You can consider it will be 3.05 mm. Okay. What are we going to get? I'm going to get it as 3.05 mm. This will be the reading with zero correction. Clear, all of you? Zero is there. 5, 10, 15, 20, 25, 30. Below, what will you have? Below, you'll have 95, 95, 90, 85, 80, something like this. Clear, all of you? Yes or no, everyone? With each division on circular scale, how much reading will be there? You will have 0.01 mm, guys. Yes? Any problem? Any doubt? With each division on circular scale, one division on circular scale will have a reading corresponding to 0.01 mm. So 20 divisions will have 0.20 mm. Okay. Understood, all of you? And I think this part also you can do. They have given length and breadth are given. Square root of the area. So square root of length into breadth you will get basically. So 9 into 4 will be 36. Square root of 36 is 6. Then square root you should do, no? So this is your length. This is change in length. This is your breadth. This is change in breadth. So what will be our area, beta? We know it. Here they have given the quantity they have mentioned is Z value, which is given as root over L into B, guys. Just now we did root AB, same manner you have to solve this. So what will I get delta Z by Z as? I will get it as half times of delta L by L plus half times of delta B by B. So Z value we already got 6. We know delta L value, we know L value, we know delta B value, we know B value. So we can get delta Z also from this. I hope you can solve this question, guys. The force of friction and tension in a string are derived from electromagnetic forces, guys. Pressure gradient. What do I mean by pressure gradient? Whenever a term gradient comes into picture, right, it is pressure per unit length. Whenever a term gradient comes into picture, it is pressure per unit length, guys. Pressure, we know it is m power minus 1, ml power minus 1, t power minus 2 divided by L you will get, which you will get it as ml power minus 2, t power minus 2. Okay. Whenever a term gradient comes, velocity gradient, displacement gradient, right, force gradient, pressure gradient, right, so whenever those terms come, they are nothing but per unit length, guys. Okay. Parallax of heavenly body measured from 2 points diametrically opposite on the equator of Earth is 2 arc minutes. What will be if radius of Earth is 6,400 kilometers? What is the distance of the heavenly body from the Earth? They are asking. Again, it comes under measurement of length, guys. In order to measure a certain object, you can take, here we have planet. Parallax of a heavenly body measured from 2 points diametrically opposite on the equator. And we are trying to measure it from 2 points on the equator of the Earth, you can take. So A and B are the ends of the equator, guys. So what will this distance be? A to B, what is the distance? Will it be 2r or not? Yes, it is going to be 2r. So how much is the diameter? What angle is subtended? The parallax of a heavenly body measured from 2 points diametrically opposite on the equator of the Earth. How much is this angle, guys? It is 2 arc minute. Okay. So they're asking what is the distance of the heavenly body. So I can say if capital D is the distance. Now what is this? This will be part of a circle which will be centered at point P, guys. P is the point on the planet. So what are A and B? AB is a part of a circle, small part of a large circle centered at point P. So how we can find the length of the arc as? Length of the arc, it can be written as the radius. So radius will be diameter here into how much angle it is subtending, guys. You can say theta or phi, whatever it is. So here you can take theta. So what will D value be? It will be AB divided by theta. What is AB here? 2 into R. What is this? 2 minutes you have, guys. So what I will get? 2 into 6,400 kilometers means 6.4 into 10 power 6. You can write what is 2 minute. Always remember 1 degree is 60 minutes. So what will 1 minute be, beta? 1 by 60 degrees. What will 2 minutes be? 1 by 30 degrees. And each degree will be pi by 180 radian, guys. Will be pi by 180 radian. So what I will get here? 12.8 you will get. Then into, this is 54 you can write, 5.4 you can write, into this is basically 540. So 5400 you will get, guys. 5.4 into 10 cube you can write, which will become 10 power 9 divided by pi you will have. So pi is nothing but 3.14. So almost 2.2 into 10 power 10 you will get, guys. This will be approximately 2.2 into 10 power 10 meters. This would be the distance of the planet from the Earth. It is called as parallax method, guys. Right? In order to measure the distance of the planet from the Earth, we are taking 2 observatory points on the extremities of the diameter, on the extremities of the equator, you can say, or the diameter. From here to here will be distance between the Earth and the planet. From here to here also will be distance between the Earth and the planet. So AB will be a small part of a circle centered at point P. This AB is subtending how much angle? 2 arc minutes. 2 minutes is given. So 1 degree will be 60 minutes. So I can write 1 minute will be 1 by 60 degree. 2 minutes will be 1 by 30 of a degree, right? And each degree will be pi by 180 radian. So into pi by 180 you can do, you'll get 2.2 10 power 8 guys. Clear all of you? Yes or no? This also I think you can do. Same concept again. Dimensions of b and dimensions of x square should be same. And dimensions of power should be equal to dimensions of b plus x square divided by a into t. From there you can find dimensions of b as well as, or you can say directly, it is direct case guys. I can write this as b plus x square divided by a into t, as simple as that, which can also be written as dimensions of b divided by dimensions of at, which I can also write as dimensions of x square divided by at guys. If you take these two things, what I can write, dimensions of power will be equal to dimensions of b divided by dimensions of a into dimensions of t. So from this I can write dimensions of b by a will be dimensions of power into t guys, which I will get it as ml square t power. Power is ml square t power minus 3 into t you will get, which is ml square t power minus 2. Directly we can solve it guys. Okay. They're asking percentage error in the measurement of difference in the lengths of two cylinders. I think you can solve for it again. L1 minus L2 you can do. You will get delta L1, delta of L1 minus L2 you will get. So you can find that out. They're asking us to find percentage error. So what I'll do, it will be delta of L1 minus L2 divided by L1 minus L2 into 100 guys. Okay. So if you do L1 minus L2, what will you get? It is 5.62 minus 4.34. So I think you should get it as how much guys? 8, 5, 4.5, 1.58 will you get? Sorry. 12 means 8. I think you will get it as 1.18. Yes or no? 18 or 28? Sorry. 1.28 you will get. This is 1.28 centimeters. And they're asking us delta of L1 minus L2. Whenever you are subtracting guys, again, here we are obtaining one quantity by performing. So Z, let us say, is that quantity. So if they're asking us to find delta Z, what will delta Z be? It will simply be delta L1 plus delta L2, which you will get it as 0.03 centimeters. They're asking relative error, so I'll write delta Z divided by Z, which is 0.03 divided by 1.28. If they ask you percentage error, delta Z by Z into 100 you can do, which is 0.03 divided by 1.28 into 100, which I'll get it as 3 divided by 1.28. If you solve for it, you will get near about more than 2 you will get guys. 2.34 percentage you will get. Clear everyone? We'll do some other questions because these questions you can solve guys, which are little bit difficult again. This is screw gauge question. If you see, each of a screw gauge is given to us and number of divisions is also given. So what we can write least count as? Least count will be pitch divided by number of divisions, which is 1 mm divided by 100. I'm going to get it as 0.01 mm guys. While measuring diameter of a wire, linear scale reads 1 mm. So main scale reading is how much beta? 1 mm. And 39th division of the circular scale coincides with reference line. So what is circular scale reading here? 39. Zero error is given. So what will be the actual reading or diameter if I say? It is main scale reading. How much is main scale reading? 1 mm. Plus least count is how much? 0.01. Into circular scale reading is how much? 39. Plus zero correction. Zero correction will always be opposite of zero error guys. So I'll write it as 0.05. So how much is this? 1 mm. Here you will get it as 0.39 mm. Here you will get it as 0.05 mm. So overall our answer should be 1.44 mm guys. Clear? Definitely direct questions you will get based on this guys. Okay. Then this question you see. In an experiment to measure height of a bridge by dropping a stone into water underneath, if the error in measurement of time is 0.1 second at the end of 2 seconds, then error in measure estimating height of the bridge is how much they are saying. So what is the situation, guys? What is the uh, basically if they are motion under gravity, as I said you, what is distance traveled in t seconds in under gravity? It is half g t square. So what will I get t square value as, beta? I'll get it as 2s divided by g. So what we can say in an experiment to measure the height of a bridge by dropping, so g value is exact here. There is no variation in g. So what we can write, s value will be proportional to t square. So I can write delta s divided by s will be equal to 2 times of delta t divided by t. Okay. So already they have given 2 seconds again. So from this you can find height, which I'll get it as half into 9.8 into 2 square. So I'll get it as 19.6 meters. This is the actual height. But they're asking us to find delta s value, guys, which I'll get it as 2s delta t by t, which can be written as 2 into 19.6. Delta t value is how much? 0.1. T value is what? 2. So I'll get it as 1.96 meters. Okay. So what is the distance traveled in free fall? It is half gt square, guys. Okay. So s value will be proportional to t square. From there we can find the error in the measurement of height. Clear? Let us do vernier caliper, vernier scale question 1. Vernier scale of a vernier caliper have 50 divisions coinciding with 45 divisions. In reality, 50 divisions should coincide with 49 divisions, guys. So this is a case of which caliper? Abnormal caliper. Even though I'll write 50 vernier scale divisions are coinciding means equal to 45 main scale divisions. So what will be one vernier scale division, beta? It will be 45 by 50 times of main scale division, which will be 0.9 times of main scale division. See whether it is a normal caliper or an abnormal caliper, least count formula will be same, guys. What will be least count formula? It is 1 main scale division minus 1 vernier scale division. This is 1 main scale division minus 1 vernier. We got 0.9 main scale division, guys. So I'll get this as 0.1 main scale division, and already main scale division is given as 1 mm, guys. So I'll get the answer as 0.1 mm only. Clear, all of you? Right? 50 divisions in general should coincide with 49 divisions, guys. But here you can see 50 divisions are coinciding with 45. So it is an abnormal caliper. Whether it is normal or abnormal, least count will still be given as 1 main scale division minus 1 vernier scale division. Clear, all of you? Yes or no? I think rest of the questions you can solve. Okay. So basic questions they were, guys. Units and measurement is very important again, right? Because direct questions you will get from this particular chapter. However, some questions which are direct, I have not discussed because of time constraint. Tomorrow also what we will do is we will directly solve questions of modern physics, guys. Okay. And before solving the questions, beforehand itself, I will share you the notes of dual nature, atoms, nuclei, right? Whatever chapters are there, I'll try to share the notes by tomorrow afternoon, guys. Okay. Clear, all of you? Any doubt in today's session?
So,
Ji, sir.
so what do we use to measure a Young's modulus?
Young's modulus?
So is it a bomb calorimeter?
No, bomb calorimeter is used to measure the temperature. It is not Young's modulus again. I think one question we got last year based on that. I think spring will be used, I guess. Just check NCRT once. They'll directly give the statement again.
Okay, so I have one more doubt.
Hmm.
Sir, if a wave is propagating and it is getting reflected, So in that case, would its value will be if there's a wave 20 sine omega t plus kx, if it is getting reflected from a surface, so would the equation be remaining the same, or it will become minus of 20 sine?
Oh, it is depending on the the end condition again. So if that end is free end, then you will get without any phase change. So it will become 20 sine kx minus omega t. Okay. If it is getting reflected from a fixed end, then it will be 20 sine kx minus omega t plus pi. Because whenever reflection of a wave takes place at fixed end, there will be a phase difference of pi. When it is taking place at free end, there will not be any phase difference. Clear?
Okay.
You
So,
said
but
equation as 20 sine. You said equation as 20 sine kx plus omega t. Yes or no?
yes, sir.
If it is usually it will travel along negative x-axis. So when it is getting reflected at the free end, it will travel along positive x direction without any phase change. So our answer should be 20 sine kx minus omega t. But if it is a fixed end, apart from traveling in opposite direction, there will also be a phase change. It will travel like this. So we write 20 sine kx minus omega t plus pi you will write.
Understood, sir.
Okay. Right. So the other doubts, if you have any, you have shared questions. I'll definitely send the answers mostly by tomorrow. Right. And if you other doubts, if there are there, we will discuss in tomorrow's class. Okay. So I have already shared the test link for gravitation and units and measurement. Please ensure that you are completing it, guys. We'll meet tomorrow. Till then, take care, everyone. Thank you all. Bye bye, all of you.